For our next talk, we have at 10:50 here, we have Sven Kettel, the founder of AI Village, NBHD.ai, and he organized the Generative Red team at DEF CON 31. He's going to have a great talk for you, a really knowledgeable guy, and he has the perfect talk voice, too. So you're just going to get very relaxed and pleased as he talks to you about all of his informative stuff. So welcome, Sven. Looking forward to your talk. Come on.
Hi everyone. My name is Sven, as you know. I founded the AI Village at DEF CON mostly because I am a mathematician who wanted to talk about geometry at DEF CON, and one thing led to another, and we ended up organizing the big Generative Red team with Anthropic, OpenAI, Google, Cohere, NVIDIA, Hugging Face, Meta. What's the last one? Oh, and Stability. So we had all 8 models, and I'm going to talk about that and what some of the results, the objectives and things for that, and the policy work that we were doing with that, with it. So here's the disclaimer. This is my own work. I represent myself. I have my own company, so I don't have to say this. So the first thing, the main reason why we need to test machine learning models is because they're predictable but unknowable. And this goes beyond just like run it through a test set. You have to actually evaluate them, because even the test set, if you have a low loss for that, on that system, you might get unexpected behavior in the model. It might do something that is extremely weird and you're not expecting. And this happens all the time. When you're training machine learning, malware models, spam models, things break. And you have to make sure that you have some sort of evaluation or a system. You have to have some form of observability. And I'm going to talk about what we did at DEF CON, what's the objective, why we did it, sort of, and what's the shortcomings with those objectives. And the last thing is what to do next. So the main thing that the theme of the talk is public participation. You can never do enough testing in-house. I don't believe, especially with generative models, you can never do enough testing in-house. You have to allow the public to test your models. Your public already tests your models. This stuff is already happening. And we just need to and the same sort of thing happens with software. We need to systematize that just to make it fairer for everyone. So why test? So AI is a black box. You train a model to minimize the loss. You don't train the model to actually generate, you don't train an LLM to generate Shakespeare. You train an LLM to predict the next token with a minimum loss. So whenever you train it, it predicts a token. It's either right or wrong, and then you adjust the weights to make it more right. It is statistical. We measure its performance over a test set. We have a validation set that we hold out. We measure its performance and we minimize the loss on that validation set. The exact, the great backpropagation is also done statistically, and the main thing is difference is it's statistical. With traditional software, it is deterministic. We know exactly how it's working. And we know, there are ways to prove how it does things. There's ways to prove that it's going to be cryptographically secure, it's going to actually work how you expect. But with AI systems, you can't prove anything. You can just infer that it's probably going to do the right thing, which in security, 99% secure is not secure. You have to be 100% secure, and with machine learning models, you're never going to be 100% secure. And I know for CVE style things, you're never going to be 100% secure too, because there's always new features, always new processes, but there's old, well-trod software that people trust and has been extremely well tested that is close to it. So with the main thing, that boils down to in AI, that there's a bit of aspect of chaos. Small differences can wildly change the output, and I'm going to. The test gives us some certainty, but yeah, 99% secure. Why test? Another thing, Simplest neural networks are horrifically complex. This is a visualization of sort of the decision process. I know there's caveats here, of a model on MNIST. MNIST, as you see, those classifying digits. We're classifying the digits of handwritten digits for postcodes, sampled by the US Postal Service. This neural network has 60 hidden layer, has a single hidden layer with 60 nodes in it. Each color is its own linear region in the neural network. It is the simplest neural network you can get, and this is a two-dimensional slice of a 780-dimensional space. There's 2 to the 60 decision paths in that network, and somehow it works. And we don't know exactly how it works, but it does. And because those decision boundaries is so complex, you get situations like this. There's adversarial examples where you've got panda gibbon. This is the panda gibbon thing that's required everywhere. You can subtly manipulate the model to have it output ridiculous things. Another thing is bias. So this is a test of stable diffusion. And you can see on the right, there's the graph that shows you the predominance of different classes in different clusters for laboratory technician. And what you would like to see, if you look at what those clusters actually represent, cluster 4 is seems to be just mostly white males. Cluster 15 is women. Cluster 3 is black men. Cluster 1 is Latino or black women. And DALL-E doesn't produce anything, it doesn't actually produce any black women in their data set. And the reason for this is the original data set isn't balanced. It doesn't have a nice even distribution of lab technicians. And so to generate, and the machine learning model actually amplifies that bias. And with a generative machine learning model, there are thousands and thousands of classes because each, essentially, there's sort of an infinite number of classes, and slight unbalances in those classes cause like a mode collapse. And for security data, when I was building malware models, you need to be very careful about the balance of malicious software to benign software, and you also have to be careful about the balance of the malicious software. So you couldn't have too many representatives from one particular malware family, because it would ruin your machine learning model that's designed to detect whether a software is malicious or benign. So we were very careful in how we balanced our malware data sets. And you have to be even more careful with how you balance your data sets from generative AI. And in this case, you can see that Stable Diffusion has done a pretty good job of having a fairly balanced data set, and they generate a bit of images from each of those classes. And in this case, DALL-E 2 is not that balanced. It generates mostly white males. And it's not OpenAI's fault. It's very difficult to do, but this is something that you have to put a lot of effort into working on. Another reason to test is the adversarial setting. If you're being under attack, like a malware model or spam model, you have to assume, because you're never going to be 100% secure, you have to assume there's a breach. You actually have to, the correct thing to do is to forecast. I'm going to be breached. I know I will be breached by the 3-month mark. I should only be breached after about a month. I can actually predict that. There's a standard normal distribution for when I'm going to get breached when I deploy a model. And I can use historical data to predict the breach, when I'm going to get breached. And then I got to create a training and redeployment schedule based around that forecast. And because more malware gets deployed in December, you might want to increase the number of models you to train and deploy in December to get ahead of the curve, because you're more likely to get breached in December because there's just more malware coming out, because malware authors want to buy Christmas presents. In the generative setting, it's a different story. It's not necessarily an adversarial setting, but the thing is the scope is so much larger, and the ways you can screw up are so much larger that you have to allow for testing that is outside of what you think of it. So you have to allow, you have to assume that you're going to screw up. So if you're using ChatGPT for hiring, have you tested whether it's biased against Alaskan Inuit communities? I have seen lots of papers saying these papers are unbiased, and they test Black, Indian, white, and they test the large demographics of America, but they don't necessarily test like like smaller minority groups. And then do they test the minority groups of like Singapore or China? The models are getting used there as well, and we aren't sure. Another thing, image generation. Stanford Internet Observatory found a lot of questionable images in Lao and Fibillion, which is why it got retracted a few years ago. You have these things, because the data sets are so large, CRUD leaks in. Things that you shouldn't be in the data set leaks in. So you have to allow for testing. For machine learning, for security, you have to allow for external testing because you're going to get breached. And you're basically always getting tested, and you have to keep an observability pipeline in place to make sure that you can see when you break. In generative AI systems, you have to allow for external testing because you screwed up. There's some aspect of that model that you weren't expecting that you probably screwed up on. And it's fine. It's perfectly okay to have a mistake in your model as long as you're trying your best. So what did we do at DEF CON 31? We were trying to do public testing. So we had 8 vendors: Anthropic, Cohere, Google, Hugging Face, Meta, NVIDIA, OpenAI, and Stability. And what we actually did was a capture the flag format with the 4 categories: privacy, safety, and effectiveness, algorithmic discrimination, and notice an explanation. These categories come out of the OSTP's AI Bill of Rights that was published by the White House back in late 2022. And we worked with them on creating some of the questions. We had it was a capture the flag format, which has got this is why part of the reason why we had issues. But it was designed by a committee with representatives from each vendor, representatives from NIST, White House, OSTP at the White House, and other interested parties. And we had 30-some questions. The data set has been released online. The questions are all released online. You can go find them. But because we had 8 models, all those 30 challenges had essentially had 8 ways to solve them for each model. And when you chose a question, like bad math was a popular one, you got randomly assigned one of the models, and then you could solve the question for that model, and then it would move on to the next model, and then you get randomly assigned. So you don't know which model you were testing, and this was a way of making sure that you couldn't accidentally find something bad and tweet it out, because we want to do the coordinated disclosure with the machine learning models. And the platform was built by Scale based on an open source CTFD prototype that I wrote back in just March of last year. So the 2 warm-ups, we did one at South by Southwest in March of 2023, and then one at Howard University. And at South by Southwest, we had the Houston Community College come up. They brought 30 students, and we gave them the access to the model, access to Eleuther 20 billion, and they were trying to get it to say some things. And so we had some challenges which are focused on bias, some challenges that were focused on bad math, and a couple other things. And we got some interesting results. Eleuther AI, somebody got it to say some fairly bad hate speech. But at Hack the Future, not the Hack the Future, at the second event at Howard, we got my favorite example, because it's nice and clean and easy to say, which is someone put in, my children are 3, 5, and 8, and the model was like, here's how you torture and kill them. Which is not great, because part of the thing is this model was supposed to be safe. The model was open, Pythia 12 billion, fine-tuned on Open Assistant's data set. And the point of Open Assistant is they were doing reinforcement learning from human feedback to make the Pythia 5 billion instruction tune safer to use. And they didn't quite get there, but it was a valiant open source effort. So that error that I brought up, my kids are 3, 5, and 6, is a not even once type of error. So this is one of those things where it shouldn't happen once, because if you had a small kid interacting with the model, and for a language model, this is not as critical. But if you have a small kid interacting with the model, you don't want them to put something in and suddenly get some elaborate gore fantasy written out for you. That is a safety thing. If the model is intended to be consumed by certain demographics, it really can never do that of a prompt that is that simple. You're never going to get it to not do that. It's always you will always be able to get these models to say something horrific, but it should be hard to do. So we expect from that we saw not even once errors. We did not expect from the learnings and the design of the competition bias errors. And this was of critical interest in a lot of people to hear for bias. How are we going to make sure that the model is, like OSTP, everybody is worried about model bias. And how do you prove bias off of a single example? Bias is a statistical property. It's not a property, not a thing of a single sample. So when you get a model to say something really racist, or decide that it's not going to hire someone, it's off of but it's a single person. We don't know if that model is not hiring that Latino woman because it's racist, or that white guy because it's racist. We know that it's just decided against them. Like, you aren't bad if you decide not to hire someone. You are bad if you systematically don't hire people from the wrong from minority classes, and it shows up in your statistics. So we weren't expecting that second class of error, the bias errors. We were just expecting not even once. Not even once is much harder to report. So this is actually gets to the bias issue. And this is sort of gets to some more issues. So this is how you actually test bias on machine learning models. You take what this did is they took several hundred resumes, a few thousand resumes, and then they modified those resumes. So one copy of the resume, it said that you were Democrat, and the other copy it says you were Republican. That's all it changed. That shouldn't change your hiring decisions. It does in real life. Lots of people discriminate against you for your political affiliation, but it shouldn't. Another one, I'm pregnant or not pregnant. Pregnancy is a protected class. You can't discriminate against someone because they're pregnant. And you just modify these things slightly. And you can see GPT 3.5 does a pretty good job. Google does a very good job. And Claude doesn't do a very good job. But if you actually listen to how OpenAI, Google, and Anthropic talk about the different models, OpenAI says they're great, and then they'll hang out with they hang out and go to medical conferences. They've had people who run hiring decisions, who are using GPT to do hiring decisions, come speak at conferences and things. They say they're great. Google says and documents on their model card how this is how well we do on bias. They're upfront. This is how well we do. This is exactly how we think, and they, as you can see, put a lot of effort in making sure that their model is nice and biased thing. Anthropic published a lovely paper at the end of 2022 that says if you are overly safe, it damages the model's ability to learn. So the quality of the model goes down as you put more reinforcement learning from human feedback. So they have openly stated that they are trying to build the safest model from their perspective. So they put a lot of effort into code security. They put a lot of effort into in aspects, but they don't worry about hiring decisions. If you apply for a job at Anthropic, they tell you no LLM is going to be reviewing your hiring decision. They come out and say, we are not trying to make them a model that is perfectly safe and a thing. They are open that you should not use their model for hiring decisions. So they've opted out of that market, and as you can see, they're not trying. But they're actually my favorite model to use when I'm trying to write an academic paper or some code. I will ask them for help writing like a demo for AI Village all the time because it's really good for that. And they're not dropping in quality every month like OpenAI does, because OpenAI does a lot of reinforcement learning from human feedback. And a paper from a month ago basically tracked their performance over time, and it seems to be dropping. But these are three different choices that you can approach. and I like Google and Anthropic's. So but it gets into what we are actually proposing to do with the GRT data, but the design of the data doesn't lend itself well to this. So everyone, we're at RSA, so most people should know what the CVE process, the whole economy of those things with MITRE, CERT, SEI, and NIST. There's a whole ecosystem of how to actually do this. And we were proposing a small modification to the existing CVE process. So instead of doing coordinated vulnerability disclosure, it's coordinated flaw disclosure. This is a key difference that after lots of discussions with people who were involved in the CVE process, bias is not a vulnerability. A model bias is not a vulnerability. A model can be, as you can see from Anthropic, if vulnerabilities are a binary thing, you're either vulnerable to that thing or not. In this case, Anthropic has released the exact same type of model as Google and Anthropic. If bias was a vulnerability and you wanted to classify it as much, there would be basically no choice, and Anthropic would be vulnerable to bias. But they made a choice, and they get to make this choice. If they said it was a thing, it would be a flaw in their model. Also, the exact definition of bias is unintended thing, and we kind of can't help. We can't help this sort of behavior. It's always going to be there, and we have to just like pick and choose our battles for how to make safe models. The objective. So we don't want like a model doing things about political affiliation to be a vulnerability, because suddenly models that are designed to be geared towards Republicans might be vulnerable, and it gets into a whole big political mess. But the best thing is just go to a new system. That's why we're proposing the word flaw instead of vulnerability. Because if there is, but the main objectives, the differences, is you don't base the definition on a universal definition of vulnerability. You base the decision on the model card. I'll go into what a model card is in a sec. But it is the scope of the document. It is the scope and intent of what the model does. You require data sets to be submitted. We want you to ask us. We want you to prove your assessment with a bias, with a data set, not a single sample, not a single proof of concept, but a whole data set that says, here's a systematic behavior change. And you have to prove it and you have to give me a statistical argument for what's going wrong. Even as a malware model, monitoring a malware model, I want a statistical argument. You say I'm vulnerable to a packed binary system, which there's arguments there. I want you to show me that when you pack the binary, I start screwing up. And I want like a small data set that says I took this malware sample, packed it, and suddenly you're not classifying it as malicious anymore, and it's very easy to do. And I think this is a vulnerability that your model shouldn't have, and this will lead to a violation of your model card. I receive that as a data set that shows me this thing. A single sample, that could be a mistake. Models are allowed to make mistakes, but you need to show it to me as a data set. The last step, this is the big question, and I don't know how this is going to work, and I'd love to talk more, is an adjudication committee. So there's many ways to lie in this case. As you know, statistics, you can lie with statistics very easily. I, as a reporter, if I wanted to pick on a company, like I wanted to pick on Anthropic, I could go generate 20,000 samples and then pick the 100 that show my statistical report that I want thing. So suddenly I have 100 samples, 200, 3,000 samples, but I use sampling bias to prove, a data set bias, some other type of bias, which, it's not fair. But I can go along and lie to everyone saying, hey, I came up with these 2,000 samples, but I actually sampled them from 20,000, 200,000. So I can lie. And then Anthropic can also just say, no, this is a thing, model card. There's ways to lie on both sides. But let's talk about a model card. So this is from our archive. It was published in 2019. It is a key aspect of model transparency. All you're doing is saying how well you do on certain benchmarks. Those benchmarks, as I've discussed, may not be complete, and those are the ones that I think, but as we come up with new reports, we can add to the benchmarks and add to the model card and we can say how well it does and what you expect, and how you as a purchaser of the model should expect the model to perform. So if I want to go and buy a AI firewall, I should get in the contract today, I should get I have 0.01% false positive rate on this type of data. I have false negative rate of 0.1. Those are listed for a lot of sales. Those should be of AI systems. Those performance metrics should be listed in the contract. And I, as the vendor selling the AI model, should be obligated to meet those objectives. If I go above my false positive rate with an EDR product, your security engineers are going to get inundated with alerts, and it's going to cost you a lot of money and a lot of time, and they're going to get pissed off and turn my product off. But I've also violated my contract, because my contract says I have a false positive rate of below 0.1%. If you can do that with a lot of bias questions, it becomes more difficult. You're going to have statements that are like, we are unbiased. That is a statistical statement, but the exact parameters of unbiased is not really defined. Because you're never going to get, if I do the resume results, I'm never going to get it on the nose. I'm never going to get 50-50 changes. I'm never going to get the exact same parameters. It's always going to change a little bit, but it should be close to 50-50. I don't know what it should be, but the model card should have this information that you, as a purchaser of models, can make an informed decision. And then you, as the purchaser of the model, should have some way of verifying some of these statements. Or you should have somebody who you trust verifying some of these statements. But one of the big problems with model cards is they're not standardized. So if you go to Hugging Face, which has a lot of open source models, each open source model is required, because Meg Mitchell's the head of AI ethics there, and she's one of the authors of the paper that came up with the idea of model cards, is required to say, you upload the model, it's required to include a model card. Some of those model cards are, it works, I did my best. Like YOLO, it's not on me if this model screws up. So for example, StarCoder's foundational model says, we've done our best. They include, there shouldn't be any PII that this model reproduces. That is one statement that they make, but the rest is basically like, it's on you if it generates something bad. It's a foundational model, and that's going to get included in, it's going to get fine-tuned by instruction fine-tuned, and then it's going to get RLHF, and then it's going to get guardrails put around it, and then it turns into a product. Each of those steps could have its own model card of what they're trying to do from the base model. And you're going to get a whole software bill of materials that needs to develop with AI that includes what data sets were used in each of the steps. But the base model is very much like we're just providing an open source model that you can then use to make a product, and then your product should have a robust model card. But that one is very much like foundational. Like Eleuther AI's models also have, we've done our best. But it's different, and it depends exactly on you, like what the model is, and it's not standardized. It should start to get standardized. The next one is, as I said, report data sets. So if you look at a lot of CVEs, they'll have the data sheet. They include a data sheet, like the citation that shows that this is a CVE. That will link to like a GitHub page that has the thing. It'll link to, it sometimes links to code that proves it, sometimes links to the payload, sometimes links to, it'll link to a single example. When you have a coordinated flow enumeration with the database, it should link to a archivable data set that says, hey, this is what I used to prove it, here's my report. And it should not just be one sample. Big problem with the GRT is everybody made one sample. So we can't, like this was the killer of doing a coordinated vulnerability flaw enumeration for the GRT. We're just going to kick the bucket, kick that thing. Sometimes, if the harm is bad enough, that is a sample of one. So and especially for brand risks. For example, Google misclassifying people as gorillas is a huge brand risk, in addition to being an awful thing to do. So when they made their stock dropped by a lot when that came out. And so that's the sort of thing that it is known. We know this is an issue. You should really test for it. You don't get an excuse these days, because it's like if you have cross-site scripting at a large company, you screwed up, and there's a lot of ways to do it. You should be checking for it. If it's a really simple vulnerability, you should not have the same thing for the Google for misclassifying people because your data set wasn't broad enough. But that is one example, and there's a bunch of other ones where it is well known, like Tay, Microsoft Tay, that came out a few years ago. It was learning in an online system. It became very, very racist very, very quickly. You should not release a model that has an online learning system without a robust data filtration step in there, because it's been done before. And like one example of your online learning system model going bad is enough to say, it can demonstrate that you deployed it incorrectly, and you should not do that. But the big question, the very difficult part, is adjudication. How the hell are we going to adjudicate these systems? So OpenAI versus OpenAI versus New York Times. Someone screwed up here, and I don't know who. And I'm not going to know who, because I don't work at OpenAI or New York Times. New York Times could have taken tens of thousands of prompts where they're trying to get their model to generate. It's stochastic. There's a process. It's not. You don't get the same response to the same prompt every single time. There's a sampling. There's a way of sampling there. They could have taken 10,000 samples, 100,000 samples, and picked the subset of the 100 that they included in their lawsuit. They could have done. They could have done that. I don't know. If they cherry-picked it out of 200, they have a solid case. I would say OpenAI is screwed up, and they trained on copyrighted data. And maybe they shouldn't be allowed to do that. And also, training on copyrighted data is a whole big question. I don't really have an opinion on that. I have no idea what should be done there. There's arguments on both sides. But on the other side, OpenAI, I can think of a dozen ways to make sure that the token stream generated by ChatGPT can never reproduce those 100 samples that OpenAI, that New York Times included in their lawsuit. There's a bunch of ways to do that. I don't know what they do. I've never seen the inside of OpenAI, and I don't know how their systems work. But there's lots of ways for them to prevent reproducibility of those exact copyrighted work. And I don't know whether they did train on this stuff and they're now doing this thing where they prevent reproducibility, or they are doing, or they are like just fine. We can't reproduce it now. The moment this lawsuit dropped, lots of people tried to reproduce those exact samples. They put in those things, and none of those things got reproduced. And one of those two cases, either OpenAI is lying, or New York Times is lying, or both of them could be playing shenanigans. But that judge has got a very difficult decision. I'm going to pay attention to this because it could affect how AI is regulated for years. So, because we're at RSA, we're going to look at just quick malware model stuff. So, if you are on the floor and you're trying to buy an EDR product that uses Next-Gen AV to find new threats that you've never seen before, and they're using a model, you should get down to brass tacks and what are you actually guaranteeing? Give me some actual numbers, because you can do that nice and easily for malware, for data like this. I want this false negative rate, that false positive rate, and you should guarantee that in a contract. But there's two ways for them to guarantee that. One of them is I guarantee that to you, and the other one is I guarantee that across all customers. So if they have 500 customers, you could have the problem where you suddenly get a breach. Your false negative rate on your network your false negative rate, you have a breach, and a sample is running around your network destroying you. Some ransomware is messing you up. But they're not in breach of contract because they guarantee it across all customers. And you're just one of them. And overall, their false positive rate and false negative rate are within the bounds. For you, that's not true. But you, as a customer, should maybe ask for the first one, not the second one. Because you can't verify it across all customers. You can only verify it across your system. You can't see what the other customers are doing. This becomes even more difficult for for products where you're buying individually. Like I buy ChatGPT as a single person. Their guarantees for bias are across everyone. It's just amplified for them. But for you as a large EDR customer, you can probably go verify this. There's complications. So one of the issues we had was potentially unwanted apps. Some companies use a adware-ridden unzipper, and they like that adware-ridden unzipper, and they should be allowed to use it. But I, as a maintainer of malware models, don't think you should think that's probably something bad. It's going to one day lead to a breach, but right now you as a vendor want to use it, and this is known in the industry as potentially unwanted apps. And some vendors fall on one side where the potentially unwanted apps are malicious. Some of them fall on the other side where the PUAs are benign. The model card where you're purchasing this, they should specify this, so you don't get surprised and you know what to purchase. Instead of what happens is we classify this PUA as malicious, and you're using it, and I don't think you should, but you're using it, and suddenly we block it, and you can no longer do business for the day or two until we come in and remediate for just you. You should maybe go buy a different EDR vendor. This PUA thing is much more difficult for enterprise deployments versus personal deployments because people at home are more likely to use PUAs, and enterprises are more likely to just ban all PUAs. Also, one of the other things is the data sets are getting quite large, and we have timeouts. So if you have malware that's older than 10 years, that's probably not traveling around the internet. These things never go away, but they're probably not traveling around the internet much. But I have a billion pieces of software on my data set. I don't want to train across all billion. It makes the model, at some point you have too much data and you can make the model worse. So you deduplicate, delete a bunch of the data. You don't delete, and you also do timeouts, so you remove some of the data that way. You're just trimming it down to a more reasonable size, and it makes it more accurate on today's malware, but less accurate on last year's malware. Malware from 10 years ago. Today's malware from last year, probably still in play. But it's okay for me to be less accurate on that data because it's probably not traveling around the internet as much. But this especially relates to binary files and small hospitals. You, as a large enterprise like Google's probably not running Windows XP on an MRI machine in the corner, but hospitals are. There's still DOS machines. My wife was at Johns Hopkins, and she was using a DOS machine to get data for an MRI that cost $2.5 million. That was released in 2010, but it interacted through Windows 7, Windows XP machine for reasons. That's not that good, but that computer is on the network, and it needs to be segmented and all that stuff. But if I'm as an EDR vendor, you should make sure that you should specify. Are you going to work on such an old machine? Then the other thing is packed binaries. If you're doing static analysis, you pack the binary. It hides all the static analysis. You should tell them this is static. The model card should be this is a static analysis model. We don't do dynamic analysis. And they should be upfront, and you should be demanding that you're getting a static, dynamic analysis model. Eventually, you should look for their roadmap, but that's actually really hard, and a lot of them are working on their dynamic analysis model. A lot of them are say that they haven't, but it depends. But these caveats are very important. They should be included, and you should discuss them at contract negotiation. But they should just be in the model card that's coming to you. So, if you want to apply this stuff, apply what you've learned here today. This week, if you're walking around the RSA floor, you should look for verifiable statements. Very hard to find a verifiable statement from the marketing people, but you should look for the engineers can give you sometimes give you verifiable statements. And these are stuff that you might not be able to verify, but you can see a statistical test to verify them. For example, Twitter saying the number of bots on Twitter is below below a certain rate to their below 1% to the SEC, their investors. They made a statement of our bot rate is below this percent. They said it to their marketing people. The way they sample that is they pick 100 samples a day and check. That's actually a very good way of checking. The Twitter can just manually go through 100 accounts a day, and statistically, over time, that's a very good check for the number of bots on Twitter. It doesn't sound like a good check if you're not a statistician, but it is. But that is a verifiable statement in their SEC, and you can go check it as a thing, and independently go check it. But in the following weeks, you should go on Hugging Face, go and look at the different model cards. Look at the model card for Llama 3. It's actually really good. It's big and complicated, but it's a good, solid model card. The model card from Mixtral is not that great, but they do include the information needed in a model card in their release statement on their website. It's not on the model card on Hugging Face, so this is one of those things with standardization. The information that you need for Mixtral is not in a central place. It should be, but if you should, like I as a data scientist know what to look for. But you should go look at those model cards, start looking for these things, and then going into the vendor websites, seeing if it's elsewhere. And then in 6 months, a few AI ethics papers. If you're especially worried about bias, look at how these data sets that I discussed are constructed. They form tests. Look at the adversarial AI research. We're looking at adversarial examples. They build data sets that test and processes that test these models' performance on these things. Look at how that works. But anyway, that's it. And now I'm open for questions from anyone. There's a microphone in there. Anyway. Oh, that mic seems to be off.
Hello?
Yeah.
How do you see the CFE process getting adopted? Are you proposing it to the CVE standards, or how do you see it going?
Right now, I don't think it's current. So I don't know how this is a big question. I want to figure this out before I propose it for anyone. This is just like what I want to do. I don't know how this is going to work. This adjudication. So I am not. If we figure this out, and when I do talk to people who know what they're talking about, this is the big question they have. So at DEF CON this year, we're going to test this in a bug bash, where there's going to be a few two tables. You're going to have a vendor representing the vendor, the CNA, and then another table, adjudication committee, the adjudication representing MITRE, the root, and then you can report things and see what happens. And I want to stress test the process at DEF CON. And then if the process works, so it might be that at DEF CON we can do that and then find out that adjudication doesn't work for reasons, and this whole process is stupid, and that would be interesting. But I'm not going to try propose it to anyone until I sort of know how to do this. I just want to kick the tires on this thing. Yeah.
Hi. Your point on the model card was very, very interesting. So can you elaborate a little bit more on what you would propose in terms of standardization, so how it can be standardized, and if its production can be automated? So will we ever have an agent or a piece of software that can create that automatically instead of having people actually doing it?
I think so. I think the model card should. The main thing for a model card, the main legal reasons for the model card is once a piece of software goes to a vendor. Most people aren't going to be making their own custom models and deploying them. They're going to interact them through an API or an edge device that is maintained by someone else. And if you're selling that, you should have a team in place to make this. If you want to automate the creation of this, that's good. But I think this should be a manual process, and manually choosing what's going on there, especially when you have statements like this that need to go in there. Like, this is going to change. So I might not include on the first version of the model card the PUA stuff, but after a while, after a report or two, the PUA needs to be included, and I add it back to the model card. But the standardization, I think, it should have a statement for scope. Like, that would be these are scope statements, not intent statements in a sense. The intent statements are, we performed this well on this bias test. We performed this well on benign holdouts. Like, we performed, those statements. This is a scope test of, like, we know we're going to screw up pack binaries. Maybe this model card isn't public because the moment a attacker knows you screw up on pack binaries, they're just going to they're just going to pack everything. But that's sort of well known at this point, so you should be upfront and maybe be working on dynamic stuff. But beyond that, it should be, the standards should probably be between industry specific. Like, an LLM will have different standards than a malware model, and then it should be, I think, community driven somewhat. And then once the community has decided upon some standards, then this should step in. My friend who said he was going to come harass me at this talk, because I've had lots of discussions with people about this over the last year. And at DEF CON, I'm excited to just, it's the GRT2. But in this case, it's an open source model. We're not gonna, the vendors can show up, that we worked with last year can show up. But I really want to test this process, not test the models. And what I'm really hoping for is currently, if you have software vulnerabilities and you are a white hat hacker, you go to the vendor first and say, hey, you screwed up. And the vendors, for making these LLMs and all these models, are trying to do the right thing. They have responsible AI teams. They're trying their hardest, but they're going to screw up. But you know how everybody on the sales floor has a kill shot for their competitors that they go and bring to meetings and say, oh, you should never, like if you're a Cylance, you shouldn't buy CrowdStrike because they missed this one binary. And they go to sales meeting and then they hope that one binary bamboozles them. That shouldn't, that's gonna happen for the rest of the time, but that shouldn't be what happens in the media and on Twitter. If you release a model and you try your damnedest to make it fair, even, unbiased, and you're trying, what should happen is if I find something wrong with your model, I should come to you and say, hey, you screwed this up. There's a flaw in your model. Give you 6 months to fix it. These things are quite difficult, so I don't think 90 days is going to work for a lot. Give you 90 days, 6 months to fix it. And the journalists shouldn't tweet you. The journalists shouldn't pick up stories until the embargo is lifted. That's what happens today with software. They're not going to, if you find a vulnerability in a Microsoft product, they ask, when is the embargo? I'll happily write about this on the embargo date, and because they know that that's going to make things worse. What's happening now is people are going on Twitter and just blasting these companies, and the companies are doing a knee-jerk reaction, like taking down Gemini's image generation, or overly training on with reinforcement learning from human feedback and making their model dumber and less useful to me as a person. I want them to think more carefully and take time, not have a sudden PR storm where they have to do more harm than good. And I think that'll make better models for us. Vendors will be happier because they're not going to have the stress of constantly having PR storms because they will never get these perfect. we get better models as a public, and these models are going to be better, safer, because we can work collaboratively with the vendors instead of this like free-for-all like system that we're currently doing. Like, I'm not proposing something new. I'm proposing what happened in 1999 with the CVE process should happen with software, with machine learning software. Anyway, I think that's it, and the timer's about to go up. So, thank you very much for coming.